All right, welcome to Lab 0, our first lab on the class server. So hopefully you found this this write-up, exactly where this video is, I assume, and let's follow it through. Let's get where we need to be. Let's get logged in on the class server, and then we'll get the starter code, okay? So yeah, this is, half of this lab is just like doing a Hello World program. So it's very easy to get at least a few points. All right, so let's get started. And so the first thing you do is you log in on the class server and you get where you want to go to work on your code. All right, to work on your lab. So I made a labs folder in my home folder. And if you want to make one yourself, it's make dir labs. And then you hit enter and it'll make that folder. For me, I already have one, so it's good. And I can cd into that. Maybe you just want to work in your home folder, but get to whatever folder you want to do your lab, and then you say gimme. So I made a silly little command called gimme for our class server, just for our class server. I say gimme, the name of the lab, so it's lab 00, @ sign, the name of the class, @ CSCI 41. Then you hit enter, and it will copy all the starter code for you into a new folder wherever you were. So I was in my labs folder, and it made a lab 00 folder with all the lab 0 stuff. So I'll cd into that. And then if I do ls, here are all the files I get for this lab. And so, yeah, there are a couple steps to the lab. The first step is to make a Hello World program. And so all of these files are for the second part of the lab. For the first part of the lab, I want you to make a new file from scratch. All right, I want you to practice doing that. So you're just going to make a Hello World program, and you're going to make a file called hello.cpp. It has to be exactly that. It has to be called exactly hello.cpp. And it has to print out when you run it, hello, comma, space, world, space, I'm ready for CSCI 41, exclamation point, and then a new line. Okay, so that's exactly what needs to get printed when you run the code. Here's how you compile it, and let me do some of that for you. So definitely do the Vim tutor to learn Vim if you haven't already, because then you could edit the program in Vim. But if you have not done that yet, stick with Nano until you've learned Vim, but learn Vim as fast as possible, please. So you can say Nano, name of the program you want to open, name of the file, sorry, that you would like to start editing. So nano hello.cpp, that's the file name I need to make for this part of the lab. And then you start typing your code. If you already wrote some, you'll have it again once you open it. And you can get back to wherever you needed to be with the arrow keys. So here's my main function. I got a space over myself, sadly. See out. So I'm gonna do most of this, but I'm gonna do it wrong. Hello world, exclamation point. And let's say that that's all I do. So I forgot to say the rest, right? I forgot to say I'm ready for CSCI 41. I forgot to say all that. I did most of it though. And then to save and quit out of Nano, it's Control X. All right, highly encourage you to learn Vim as fast as possible though. But yes, I want to save Y, save it with the same file name, enter, and I've made this file. And then to compile and run, I can say g++ hello and -o, hello, name of the same program without any extensions is the default way. And here now I have a runnable program. And to run my program, I say // it's a // it's fallen forward, hello, hit enter, and it runs my program. So it printed hello world and it broke the line because I see a new terminal prompt on the next line. So I forgot to say the rest of all this. I'm ready for CSCI 41, and that's okay. I just won't get a good score. Okay, but like that's the start of it. I pretty much gave you the whole answer, so at least you'll get some points very quickly. So that's the first part of the program. So get that working, get it compiled, get it running, get it right. And then the last part of the lab is definitely the longer part. I would like you to write a program around the idea of drawing boxes. All right, so that I've made a class for us, and I've split it up in between like a header file and a CPP file. So I've got the declaration of a class called the box class, and I've got an implementation file of everything in that header file and the CPP. All right, so let's take a look at all those things. So the rest, everything else that has the word box in it is part of the next part of the lab. So box H and CPP, those are the box library itself. And then run box and test box are two files with main functions that let you get it working, all right, to see the fruits of your labor. But let's look at box.h first. So this is a class, header file guards and everything, called box, that wraps around the idea of drawing a box to the screen. All right, so what does a box need to start it off in its constructor? You need to know the width of the box, how wide do you want it to be, and then what character do you want to draw the box with. By default, we'll make it be a star. All right. And then we've got getters. What's the width of my box? What's my box character? Set it to a different one. Plus equals increments the width of the box. We'll have a minus equals to decrement the width of the box. So this is practice using using operators. And then an output operator that's a friend, because we'll need to access some of our member variables inside of it, that takes cout, whatever ostream we're given, and a reference to the box that we want to print. And we're going to try to implement this to print our box in a pretty way, right? Draw our stars, like if it's a 3x3 box, draw 3 stars and a new line, then 3 more stars and a new line, etc. Okay, so that will work. And by the way, I'm saying standard : for all the things that are in the standard library in the header file. And the reason we do that is because every time you include a file, like every time you include this header file, if I were to have said using namespace standard in a header file, this is now copied and pasted that into everybody's code. And some people don't like to use namespace standard. They really do. Like they made their own cout. You don't want to poison their namespace. And so you can never say using namespace standard in a header file. All right, those are just the rules. And so I got to spell it out. Standard : ostream is the type here. Okay, everything else is happy. But I wanted to say that. Okay, and so these are the things, and your member variables are, of course, the width of the box and the character you're going to use to draw the box. But this, I hope you can see, this is a class that wraps around the idea of drawing a box to the screen. Okay, and then your job is to implement box.cpp. So box.cpp will have the implementations of everything in the header file. So you got to include it, and I've already done that for you so that you know every definition. But your job is to implement the methods defined in box.h and also all the functions, because some of them are functions. Box.h has, like, all these guys are methods, right? But everything that's a friend, everything that's a friend is really a function. So this is the declaration of a function that needs to appear, that we've made a friend of the box class. All right. Also, this is just a function, right? It takes the two things that you're that's on the left and the right of this operator. Same with this one. Okay. So those are just functions, but the other ones are methods above. And so implement them all here and get it working. All right. And then your job is to use that library in tandem with some other files that like have a main function that actually use your library. So runbox is like a simple program that lets you test your box stuff pretty quickly. So runbox.cpp, that's another file that I've given to you that just got a main function, and like it makes a box. You ask it, the user, for the width in the box character. It makes a box using those things, and it tries to use your output operator. It gives the box B that it's making here to cout, so it's using that output operator that you made. And if you run it this way, and you say, like, I want an width 8 box, and I want you to draw it with dollar signs, it should print this. This is the implementation that the output operator should like get at, right? It should achieve this output when you run this line. And so, yeah, all of these things are working together. If you want to compile runbox.cpp, remember that you have to give the library itself. Got to give boxes implementation. So you got to give both of those to G++. G++ runbox.cpp and box.cpp. And then you call it whatever you want. Call it runbox, like I did here. Okay, so this file, runbox.cpp, is just for you. You're not going to turn it in. It's just to see visually if the thing's working right. All right, and yeah, that's kind of how that works. This will guide you to implement box.cpp, which you are turning in. All right, you're turning in box.cpp. You're not turning in box.h, but you're not allowed to change it because I'm testing you with the original box.h. Okay, so keep that in mind. And then the last step is I've got one more file with a main function, and it's called testbox.cpp. All right, so if I go and look at that, that's another file that we can compile with our library. So again, you can give that one in the box library implementation. This has a searcher. These are actual tests that are going to be run. All right, so it's running all these tests, and here's their implementation. All right, this is making sure that a box of width 0 because that should be the default constructor. But if a box has width 0, then we should be drawing nothing for the output. And it's using string streams to do that output. So in addition to files and cout, another class that lets you use this output operator is called a string stream, and you might want to look into that. I'll give you some more information about that in a future lecture. But a string stream is, if you go to this documentation page, it will give you more information, but it lets you make like a fake cout, kind of a fake file that you can use just in memory. It's really keeping track of a string, all right? And you're building up a string, and you get the string that you built up with .stir, and that's what I'm testing against. The string that I built up by putting the box B and having it print into that should be nothing. Okay, that's how that's supposed to work. So yeah, inbox.h, you see that the default is width 0 and a star. So that's what I wanted to say there. Oh no, something's happening. There, back to where we were. Here's another test, like draw a box of width 1 with $signs. It should just be a single $sign, right? It's 1 by 1. So the output should be a $sign and a new line. That's it. Then a width 3 box with percent signs should be, like the width should be 3, the box character should have been set properly to that. And then the output, once we output it, should be 3 lines of 3% sign boxes with new lines. That's what should be output, and we can check against that by building it up in a string stream. So it's a nice little type that we can look into, okay? So get all my tests passing. Like here's another one. It's like, it's making sure that set box character changes it from something old to something new. It's printing with percent signs now instead. And here's me checking in a fancier way and making sure that your operators are working properly, like your plus equals and your minus equals. These are supposed to, like, if the width starts at 1, this plus equals 2 should change the width to 3 now. Yeah, that's what I'm checking against. And the output should be a 3 by 3 box. And then if you subtract 2, the width should be 1 again. And then if you try to draw the box, it should hold just a 1 by 1 box, a single star and a new line. Okay, so I hope you can see what it's kind of checking against. And I want you to get those tests passing. All right, see passed in the output. And then your final job of this lab is to write 6 more tests in the same style. You're like, print it with A's and B's and X's and Y's, that's fine. But make 6 more tests in the same kind of style that's going to call assert true. All right, so assert true should be called exactly 6 more times. So 6 from yours, I guess 5 from mine. So you should see like passed 11 times in the output. All right, and I've got an auto grader that's going to be checking for that. Okay, so that, my friends, is your lab. So please yell at me if you have any questions about any of this, but I hope you can kind of see what you need to do. Definitely run it on your own, and definitely do the run box first to get like the simple things working, and then check hard against the existing real tests, because those are part of the things that are giving you grades. So yeah, your job now is to finish all that stuff and then submit your code. So I made an auto grader for this class. You can submit as much as you want up until the due date, but the last submission will be your score. So don't just submit piecewise. The last submission you ever make will be your final grade for the lab. So make sure that you get 100% and you submit every file. And here's how you do it. All right. So you say turn in. I made another nice command for us called turn in. You say turn in. Got to be in the folder with all your stuff, of course. So you say turn in, and just like you said for gimme, you say the name of the lab, lab00, @ sign the name of the class. So you say 41, and then you give all the files you want to turn in, all right? And might as well just turn them all in for fun, even though I've only worked on hello.cpp, that's fine. And then you hit enter, and it will start auto-grading this assignment. It should go pretty quickly. Let me know if you see any errors, but it's like submission grading started, submission grading finished, uploading the grade to the class website, and then it says auto-grading is complete. Press Control-C to close this submission program, and that's Control-C even on a Mac. That'll get you back to your terminal, all right? And I would like you to look at your grade always on the class website if you can, all right? So I've made you a view grades command that also works, but I won't teach you how to use it. You can use it yourself if you'd like, but it's nice and color-coded if you look at your grade on the class website. So let's go there. So make sure to log in, find it, and by default, you've got same username as the class server if you haven't tried this yet, but the password is not linked to your class server account. So if you haven't changed your password on the class website, it's still your username, okay? So here we go. And then I can say auto grader grades. That's where you'll click. And you should see your lab here, lab 00 at CSCI 41. And you click it, and that'll show you your score. I got 0 out of 35 because I did nothing right, okay? But the reason I want you to look at your score on the class website is because it's very helpful. It shows you like what you did wrong. See this? I worked very hard on this. So on the left side is your output for the Hello World program, and on the right side is what it should have been. The minus and pluses are not part of your code, though. The minus is just trying to say, like, if you were to subtract this line and to add this line, then it would have been correct. But it's also highlighting what needs to be changed, so it's useful, all right? So the minus and plus are not part of your actual output, or the correct actual output, but they're just helpers to say, like, oh, so if you subtracted that and added this, it would have been right. But you see, like, okay, that's what I was missing. I'm ready for CSCI 41. You might also, it's harder to see, but you might also be missing the new line, and it sometimes highlights that properly. That's a hard thing to highlight, though. But think about new line if it all looks the same. And yeah, that's why I scored 0 there. But I can recompile, resubmit with the correct version now that I've made it work. And I know what to change, so go change that. And then the rest, like your tests, and then the original tests from me, I just get a complete error message and a 0 because I never implemented anything. So I get a bunch of linker errors, like I never actually implemented the constructor for boxes, and like that's necessary for every single test. So that's why I get 0s there. But once you get them working, it should all work out, and you'll know that you had it working because you already, like, you started, right? And you saw it run and you saw it pass because you already did this first in theory before you submitted. So oops, didn't mean to do that. But I think that's all that I wanted to say. So you can keep on submitting up until the due date. So check Canvas for the exact due date. But I think that's all that I wanted to say. You can keep on turning things in. Your last turn in is your grade, so turn in every file. And make sure to always look at your grade from the auto grader. Refresh that page on the class website, go back. Because if it marks you down and you miss the deadline, like I got to give you the late credit only, okay? So the auto grader lets you keep on submitting as much as possible. It is also very picky. That's the give and take there. So just make sure you got the full credit before you stop looking at the lab, all right, before you forget about it. So just look into that. And here's the rubric. And I think that is a successful video that goes over your first lab. So just watch that due date, make sure that you've got everything working. Start as early as you can, all right, just to make sure you're back up to speed and you remember how to do C++. And I think that's all that I wanted to say for this Lab 0. Please let me know if you have any questions about anything. Start as early as you can, and I'll see you in the next one.